Welcome to module 26 of object oriented analysis and design. We have been discussing about UML diagrams, introducing variety of diagrams. We have already discussed about the use case diagram at length. Next diagram that we take up is the class diagram, which is possibly one of the most important diagrams in the representation of a system. We will in this module start the discussion on class diagrams, and this will go over to the next two modules as well. In this module, we just specify what is a class diagram and discuss the basic representation of class, property and operations. We will take up examples as well. So, before we get started, let us quickly recap on what is class. So, we have discussed the concept of class and objects at length. So, a class represents the generic footprint or the generic layout of objects that exist, the concrete entity that exists as object, and we had seen that for a class like faculty, these could be the object instances, and the class as an abstract will have different properties or attributes that define this class. We have discussed earlier also about canonical form of complex systems, where we observed that a system could be looked at in two distinct views. One is the is a hierarchy or generalization specialization view, which is primarily the representation of the class structure. We have also seen that it can be looked at as a part of hierarchy, which is the has a relationship, which represent the object structure. Class diagram is unique in the UML representation, because it provides us the mechanism to define the part of hierarchy or the object structure and the is a hierarchy or the class structure together in the same diagram. So, we will take a look in terms of how this is done. I would also like to remind you that we have seen that at different phases of the software development life cycle or SDLC, different UML diagrams are involved, and right from the beginning, that is in the requirements phase, the class diagram along with the use case diagram come in and start playing an important role. When we talk about class diagram at the requirements phase, it is often that the attributes and operations, so properties and operations, may not have been very clearly defined, may not have been totally identified. It may be more that we have the abstraction, the concept of a class that we have been able to identify, and we are still looking for, or maybe we have some of the properties and some of the operations, but we may not have been able to complete that whole thing. So, here the classes are being identified as domain models, because we are trying to capture what the domain has. This is where the class diagram is supplementing the use case diagram. In the next SDLC phase, which is the analysis phase, we analyze the class diagrams that we have captured earlier, try to refine them further, continuing to represent the domain models that represent the information that the problem domain has, and build up the UML representation of the problem, along with several other behavioral models, which we will discuss in subsequent stages. Further in the SDLC, the next phase talks about the design. It is called the design phase, where we have seen that the design is further detailed in terms of high level design and low level design, and possibly at this stage we are making use of the class diagram. The class diagram belongs here now, the structural model, and these are the new additional diagrams that are coming in. Now, in the design phase, the class diagram is a further refinement of the domain models, and in addition you may have implementation classes. That is, now we are in the design process. So, we are the output of this would be actual classes that we would start coding, possibly in C++ or in Java and so on. So, it is likely that besides the domain models, we will also have specific classes added to the design, which will talk about the implementation aspects of the whole design. So, class diagram, as we see, play a role in all these three phases very critically. In other phases also it will be required, but usually the development of the class diagram will remain limited to these three phases alone. So, given that a class diagram is a UML structural diagram, you would recall that we have talked of structural diagrams and behavioral diagrams. Class diagram talks about the basic structure of the design system at the level of classes and interfaces. Interfaces we will talk about more. Interfaces are like classes where we may not know the details of the properties that are inside, but we know just the operations that we want to satisfy. Interfaces could be generalizations of various different class concepts and so on. Besides that, the class diagram will show the features, the constraints, the relationships. This is most important, and we have talked about variety of relationships in terms of association, generalization, dependencies and so on, and we will see how all of these in terms of the class diagram can be represented. Typically, class diagrams are of different kinds. Most of them are either domain model diagrams, where basically I am capturing the domain information from the problem, which will significantly happen in the requirements as well as analysis phase. And the other type are the diagrams of implementation classes, which will be added further as we move from the analysis phase to the design phase. So, implementation class diagrams which represent implementation classes naturally have far more details than the domain model class diagrams. Now, before we can start the representation of classes, let us remind ourselves that there are the major features of the class include that a class has non-static features, that is where the individual instance or every object instance of a class will have these features. So, these are called non-static features. We have static features, where there is some characteristics, some feature may be property or operation, which is a characteristic of the class itself, not of the specific objects. For example, if we talk of that we have a property to define count the number of instances of a class that we have constructed, then this count will be a static feature, because every object will not have a separate count, because it is just one of those objects, but at a class level we will have a static count property, which will keep the count of the classes that have been count of the objects that have been constructed. Accordingly, we could have operations also which are static. For example, the operation which will actually update this count when an object is constructed, will update it when an object is destructed, or when you want to know how many objects of a class exist and so on. In other terms, there are structural features or attributes, and there are behavioral features or methods or operations that will be involved in defining a class. Now, coming to the notation. A class will be typically depicted in terms of a closed rectangle which has a solid boundary, and in between that, within that boundary, the name of the class must have a name, and the name of the class will be written in bold letter with the first letter in the uppercase. That is a basic convention. So, we will not write a class like this, where the first letter is not uppercase. This is the correct way of doing that. Some classes could be abstract. If a class is abstract, then it can be, we will write within curly braces after the name of the class that it is abstract. What it means is this class only has the concept, but in the realization we will never actually instantiate the class and create objects. Abstract classes in an alternate form could be represented by writing the class name in italicized font as well. Finally, a class may have optional compartments, that is, I have a class, say this is the class, the name of the class is say book. I may have further compartments, one compartment for the properties and another compartment for the operations, but these are optional. I may have both of them, I may have only one of them, I may not have any further compartment at all. Now, coming to the description of properties, a property is written. So, typically you can see that let us say this is one class, this is a class name, this is the first optional compartment where we show the properties, and let us say we are talking about this particular property. So, what it has? Certainly, this is roll number is a property which has a property name. So, after the property name, we put a colon to separate it from the type of the property. So, string is the type of the property. So, roll number colon string says that roll number is of type string, where it is assumed that string is something which is known already. If it is not, then that will also have to be represented. So, those of you who may be familiar with C++ and Java will relate that we keep the similar information in a C++ or a Java class, but it is just that we write them in the different order. We first write the type name and then we write the variable name. Here we first write the property name and then we put the type of which it belongs. So, that is this part. Then it is prefixed with a symbol which could be one of plus, hash or minus. They mean the visibility of that particular property or that particular data member. If a property is public, it is meant that any other class can access that property directly. If it is private, it means that only the operations of that specific class can access that member, access that property, but no external class, no other class can access that property. And finally, if the visibility is protected, then we have something in between this. If I have one class, say employee, and if we have another class, say manager, so that they are related by on is a hierarchy, that manager is an employee, which means that every manager satisfy all the properties of an employee, but may have some additional properties, some additional operations. If such a specialization exists, then for a protected member in the base class, the derived class or the class that specializes the base class can access these protected members, but other classes cannot access the protected members. So, protected visibility tells us a different kind of access restriction, where for a child class or for a specialization, protected members are like public, they can be accessed, modified. Whereas, for any other class which is not a specialization of this given class, the protected members are like private. So, as we define the property, we also define the visibility of that property. Then we may have an optional qualifier that follow the type name, which say certain specific things about that property. For example, here we are saying that a roll number is within the style is to put it within curly brace, and these are the different qualifiers that I could have. So, if I say unique, it means that of all the instances of this class, this particular property will always take distinct values, or in other words, I cannot have two students, we are representing the student class, I cannot have two student objects which have the same value on the roll number property. So, several such are possible. I can make something read only. If I make something read only, then that property can only be read, it cannot be changed. It is whatever is set at the construction time of the object will remain as such. A property may be optional. If a property is optional, then I can have null values for it, that is, it is not necessary to have a specific value at the time of instantiating objects. A property could be static, so that it operates only at the class level. A property could be ordered, that I can say that between different within the different values will have to occur in a certain order, and so on. So, the other way to say if a property is static is also to be able to underline that. So, if you underline that, that also means that a property is static. Now, the property could have multiplicity. This is important, that it could happen number, I could have number of them. For example, here I have a subject, visibility is public, is of type subject, which means that there is some other class subject. So, we are saying that this subject property is an instance of this subject class, but what we additionally have here is 1 dot dot star, 1 dot dot star. This defines the multiplicity. So, it says that I can have one subject, I can have two subjects, I can have arbitrary number of subjects, of course, more than one. So, we can specify a fixed number here, we can specify a range like this, we can specify a range which is bounded, and so on and so forth. So, that is the basic sense of the multiplicity. Certainly, the multiplicity by default is 1. For example, here nothing is written. So, the multiplicity is 1. So, there is only one date of birth property here. So, if we do not say anything, it is 1, and of course, that is the minimum value that you can have. Then some properties like this one is written with a forward slash before the name. So, you are saying this forward slash means that this is a derived property, which means that this property by itself will not be stored, but there will be some operation through which the value of this property can be computed whenever I want to access it. Try to see the reason. We are saying this property is age. For several applications, I will need to know what is the age of a person, the age of a student. Certainly, we cannot store the age, because certainly with every passing day the age is potentially changing. So, we cannot update that data. So, instead what we do? We store the date of birth, and we will possibly have some method, some operation like say calculate age, which will be associated with this derived property age. So, that whenever we want to access the age property, this operation will be invoked. This operation will consult the date of birth, consult the date that is today, and based on that compute the age and give us the value. So, in terms of the view of the object we will see as if there is a age, but there will nothing be actually stored. So, this is the concept of derived property, and we will see the use of several derived property in the design. Moving on, the next that we need to specify is certainly operations or methods. So, they are written in this form. Say every method has a name, and the fact that it is a method is shown by having a pair of parentheses after that. It is separated by colon from the return type. So, this says this will read get certificate is a method in student, and it will return certificate. Record attendance is a method, is an operation, and it will return a bool. So, again you can see that compared to the common object oriented programming languages like C++ or Java, the style here of expression is little different. We first write the method name, and then we specify the return type, and the return type itself is optional. So, I may have a method which does not have a return type, which basically means that it is not expected to return any value. So, if you think in terms of C++, then its return type would be coded as void. Methods have similarly different visibilities, and the visibility notation is same as of the attribute. So, they could be public, protected or private. Methods can be qualified by different qualifiers, like we are saying get certificate as a method is qualified by unique and ordered, which means that this method will produce results which are a number of certificates. You can see the multiplicity is star, which means any number of certificates, 0 or more. But what it says that it is unique. So, if it returns a list of 3 certificates, then these 3 certificates will have to be unique. They are ordered. So, there is some ordering between them. For example, the ordering could be the level of education for which the certificate is provided, the 10th standard certificate, the 12th standard certificate, the graduation, the undergraduation certificate and so on. So, these are the various different types of qualifiers that are possible: ordered, unique, abstract, sequential, guarded, concurrent. These sequential, concurrent, these are qualifiers to take care of concurrency in the system. So, that there are situations where a particular operation may be invoked by more than one object at a time. So, if you say that a method is concurrent, then it is possible to invoke it by multiple objects at the same time. But if you say it is sequential, then it necessarily means that you will have to do one and then you can do the next. It could be guarded, a operation could be guarded, wherein it means that the operation has a precondition, that is, I can invoke this operation from an object provided certain guard condition is satisfied. So, these are the typical ways to denote the operations or methods of a class. So, if we just refer to our LMS example. So, LMS, as we have seen, have 2 major abstract classes, employee and leave. There are several specializations which we have seen earlier. We are not talking about that, we are just talking about the abstract classes. So, there could be several properties of employee: name, employee ID, gender, salary, the date of joining and so on. And there would also be several operations like recording attendance, cancelling leave, requesting leave and so on. And we have seen how these work, how this can be extracted, and here we are just making a representation for that. I would draw your attention to this. For example, for leave we will have something called is valid. So, if is valid is true, then that leave can be processed. If it is false, then that leave cannot be processed. Naturally, we do not expect that while the leave is created, somebody is entering a value for is valid, but this will relate to some operation, say validate leave, which can have the result of a boolean, which will be set when I try to access this is valid property. And therefore, you can see this slash here, which say that is valid is a derived property of the class. I have also included here a couple of other examples, which we can just take a look at. For example, here is a library domain model, that is, this is trying to capture the information of a library. So, there is a book class, which has all these different properties of the name of the book, the subject of the book, the publisher of the book, the ISBN number of the book, and so on. There is another class book item. So, the difference between book and book item is, so when I say that we are going to follow the object oriented analysis and design by Graham Gooch et al., then we are talking about a book. But then when I study, I need a specific book that I own. When you study, you will have a specific copy of Gooch's book that you own. So, among if 5 of us have 5 copies of Gooch's book, all of them will be represented by the same instance of the book class, but each one of these copies are distinct. So, there will be some more information like say barcode, which will be put on each copy to distinguish one copy from the other. There could be a RFID tag and so on. And since these book items, specific copies can be loaned from the library. So, there will be certain derived attributes like loan period, like due date. So, you do not specify the due date, but what you keep is possibly the date on which the book has been issued, and you keep information in terms of what is the issue period that the library allows. Based on that, whenever I try to access due date, there will be some method which will compute the due date property and give me that date. Similarly, there could be. So, these are all different derived properties that we have. You can see that this is in a sense a little bit simplified model, because we are talking about the domain. For example, it is not showing the visibility specification for these different attributes, because that will get decided based on getting all the different classes together, and when we go towards actual implementation, then we can decide as to what is the or what are the properties that we want to hide, what are the properties that should be publicly available, and so on. So, here since we are just capturing from the domain, we have not yet done that exercise. So, you do not see the visibility specification symbols. So, similarly, there are several other classes like a class defining an author, which is a name, biography, birth date of the author. The library itself is a class which has a name and an address, whether it is the National Library or situated at Kolkata, which is a central library of IIT Kharagpur, and so on. So, there could be library instances coming in here. There could be librarian is another class which has different attributes and so on. So, in this way you can see a whole lot of classes that are captured from the library domain to represent the start building up the class diagram. You also of course see lot of other symbols, and some of which we have casually talked of while we introduce different concepts, but we will come to discussing those once we have actually talked of the relationships. Finally, it is the same library domain model. The only thing that is provided here, that in addition to the actual model, you have lot of annotations given. So, these annotations, this will basically help you prepare for your understanding. So, that it specifies that this is an abstract class, and you can see how do you know this is an abstract class, because you know that it is written in an italicized form. So, these are different attributes as marked here. Then rest of the stuff you have not done yet. So, you can study this and understand and get familiar with the way the classes can be represented in the class diagram. To conclude, we have introduced the class diagram. We have shown the representation of properties and operations in a class, and we have shown a couple of examples. In the next module, actually in the next two modules, we will talk about different relationships amongst classes that we had studied earlier, how to represent them in the class diagram.